Okay, let's unpack this. Welcome to the deep dive. We're here to, cut through all the noise and get straight to the good stuff. Today, we're diving headfirst into the a pretty wild world of software development. It just keeps changing, right? Our mission, basically, is to give you a quick but solid grip on the very latest, most important concepts shaping software in 2025. We want you walking away feeling like you really get it, but without your head spinning. Focusing on those cool facts, those aha moments.
Yeah, and what's really interesting is the source material we're working from. It's super distilled, like notebook jottings, meant for a quick refresh on trends. So this means we get straight to the core ideas. It's almost like a cheat sheet for what's next in software. Really highlights what's driving innovation.
Exactly. This deep dive, it's really going to show what's pushing things forward in tech. We'll
Yeah.
try to simplify some, let's face it, complex ideas and show you how they actually affect the digital world, the apps you use, all that stuff. Should be a fun journey. So let's kick things off. A big one. Microservices architecture. The basic idea is breaking big apps into tiny, independent services. So for someone maybe just starting out, what does this actually mean for building software today? Why break things up?
Well, it's huge because it changes how companies can innovate, how fast they can move. Think about like a big online store. Flash sale hits. If one small part, say the recommendation engine, fails in an old-style monolith app, poof, the whole thing could go down.
Right, total failure.
Exactly. But with microservices, that one bit can fail, get isolated, maybe even fixed, while the rest of the site keeps humming along taking orders. That's kind of an aha moment. You move from all or nothing to more resilience. Different teams can work on their own bits independently too, much faster.
Okay, so what tech makes this work?
You need tools to build the services, like Spring Boot for Java or .NET Core. Then, Docker and Kubernetes are pretty much essential for packaging them up and managing them. And then you have things like API gateways Kong, maybe Nginx as the front door. Service meshes like Istio handle the complex chat between services. And tools like Kafka or maybe gRPC for fast communication let services talk without being directly tied together. It's all about independence.
Makes total sense. Independence, faster fixes. Okay, speaking of cutting edge, this is where it gets really interesting, I think. LLM integration. Large language models. It's not just chatting with an AI anymore, right? Now apps are embedding things like ChatGPT, Claude, Gemini directly. What new stuff does this actually unlock?
Oh, it unlocks a ton. And it's moving fast. We're going beyond simple chatbots now. Think AI that generates super personalized content for you right in the app, or automates really complex tasks, even summarizing huge documents instantly.
Like a legal app summarizing a contract?
Exactly that. Or customer support drafting smart replies based on past chats. For the developers doing this, they're using things like the OpenAI API, obviously. Frameworks like LangChain and Llama Index help manage the complex back and forth with the LLM. And you need things like Pinecone, these vector databases, to handle the kind of data LLMs need for understanding context. It really changes what an app is.
So we've got these modular, intelligent apps, but just building them isn't enough. They need to be solid,
Yeah.
reliable, secure.
Yeah.
Which brings us to testing. Test automation, TDD, BDD. Test-driven development, behavior-driven development.
Yeah.
What's the big mindset change here versus, the old way of testing?
It's a pretty fundamental shift, actually. Instead of writing code, then figuring out how to test it. TDD says write the test first.
Test first, really?
Yeah, it forces you to really think through what the code needs to do, what its interface should be before you write a line of implementation. Leads to cleaner code, fewer bugs. BDD is similar, but uses like plain English scenarios, helps bridge the gap between tech folks and business folks.
And the tools.
Lots of them. For Java, you've got JNet, TestNG, Cucumber. For JavaScript, Jest, Cypress, Playwright are really popular. And what's really hot now is AI helping write tests. Tools like Codium AI are popping up, helping automate test creation, finding edge cases humans might miss.
Baking quality in from the start. Yeah, I could see how that's a game changer. Okay, another foundational shift. Infrastructure as code, IAC. Sounds technical, but the idea is managing all your servers and stuff through code, not clicking buttons. You said program your data center? How's that different?
It's completely different. It brings software practices to infrastructure. Think version control, but for your servers. No more unique hand-built machines, snowflake servers, we call them. With IAC, your setup is defined in code. It's versioned, testable, repeatable.
So you can spin up a whole environment just by running code.
Exactly. In minutes. Need a disaster recovery environment. Run the code. Server dies. Run the code to replace it. No manual rebuilds. Popular tools are Terraform, great for managing stuff across different clouds like AWS, Azure, Google Cloud. There's AWS CloudFormation specifically for AWS. And Pulumi lets you use languages like Python or TypeScript. And this ties directly into those CI/CD pipelines we'll talk about. GitHub Actions, GitLab CI. They often trigger ISC tools to automate infrastructure changes too.
Automation reproducibility again. Okay, that makes sense. And that leads us right into containerization and orchestration. Docker and Kubernetes, we touched on them with microservices, but they're everywhere now. Simplifying deployment, making scaling easy. How do Docker and Kubernetes work together? What's the synergy?
They really are a power duo. Docker lets you package your app with all its bits and pieces into a neat little isolated box of container. The key is consistency. If it runs in a container on your laptop, it'll run exactly the same way in testing, staging, production. Kills the works on my machine problem.
Okay, so Docker packages it up. What does Kubernetes do?
Kubernetes takes over managing all those containers, often thousands of them. It's the orchestrator. It handles deploying them, scaling them up or down based on load, restarting them if they fail. Self-healing. Think of it like an OS for your whole cluster of machines. Trending tools. Well, people use K8s with Helm charts to deploy complex apps easily. And K9s is a really cool command line tool for watching and debugging your Kubernetes clusters. Gives you great visibility.
Ah, okay, the orchestrator role makes it clear.
Yeah.
So, zooming out a bit, let's talk DevOps and CI/CD pipelines. Continuous integration, continuous deployment. This is all about automating the whole path from code check-in to running in production, right? Breaking down walls between dev and ops. What's the ultimate point?
The point is speed and reliability. Getting features and fixes out faster but safely. Gets rid of that big, scary release day. CI means devs merge code often. Automated tests run instantly. CD automates pushing validated code changes all the way to production, sometimes many times a day.
And the tools for this?
Common ones are Jenkins, the old workhorse, but also GitHub Actions, GitLab CI, Circle CI are very popular, especially cloud-native ones. Trends here, more safety nets. Automated rollback. If a deploy looks bad, the system automatically reverts. Canary deployments release to a small user group first, watch carefully, then roll out wider, like the canary in the coal mine.
Clever.
And GitOps is big, using Git, the code repository, as the single source of truth for everything. App code, infrastructure code, deployment configs, makes the whole system declarative and auditable.
Faster, safer, automated. Got it. Now, something critical that's getting way more focus, zero trust and secure development. The idea that security isn't tacked on at the end, it's built in everywhere. You never assume trust, always verify. What does this mean practically for developers day to day?
It means security is everyone's job from the start, not just some separate team. You build controls right into the app, so practically, you're using things like OAuth 2.0 or OpenID Connect for handling logins and permissions securely, defining exactly who can do what. JWT tokens, JSON Web Tokens are everywhere for securely passing user info between services without hitting a central server constantly. Things like strict API rate limiting are essential to stop abuse, and you use tools during development. OWASP Doc to scan for web vulnerabilities, SonarQube to analyze code for security flaws, Snake to check your open source libraries for known issues. It's about shifting security left earlier in the process.
Shifting left. Makes sense. Okay, next up, serverless and edge computing. Serverless means basically you just write code. The cloud handles the servers, AWS Lambda, Azure functions. Edge means running code closer to users, Cloudflare workers, less infrastructure hassle, lower latency. What else? Any catches?
The big win is focus. Devs focus purely on the code, the business logic, not patching servers or scaling infrastructure. That speeds things up a lot. Often it's paper use too, which can save money for spiky workloads. Edge computing, yeah, the low latency is key for real-time stuff, IoT, anything where speed matters geographically.
And the catch?
The main trade-off, often, is managing state. Serverless functions are usually stateless, they run, do their thing, and disappear. So if your app needs to remember things between requests, you need to design for that carefully, maybe using external databases or caches. It can add complexity if you're not prepared.
Interesting. Different architecture thinking needed. Okay, what about monorepos and modular code bases? A monorepo means keeping all your code, multiple services, libraries, in one giant repository. Now, hang on, didn't we just talk about breaking things apart with microservices? Isn't this the opposite?
Yeah, it sounds like it, but no, not really. They solve different problems. Microservices are about how you deploy and run your services independently. Monorepos are about how you organize your source code.
Ah, code organization versus runtime organization.
Exactly. A monorepo can actually make managing microservices easier in some ways. Sharing common libraries is simpler. Everyone uses the same version. Centralized config is easier. And a big one, atomic commits. If you need to change an API and update all the services that use it, you can do that in one single commit that touches everything. Makes refactoring across services much safer.
Okay, so tools help manage this giant repo.
Yeah, you need tooling. Turborepo and Nex are popular for front-end stuff. Lerna and Bazel are often used on the back end. They help manage builds, tests, dependencies within that single repo structure.
Got it. So not a contradiction, just a different layer of organization. Okay, observability and monitoring. Critical for knowing what's actually happening out there. Often hear about the three pillars. Logs, metrics, traces. Why all three? What's the difference?
You need all three because they give you different views. Logs are detailed text records of events. User X logged in at time Y. Great for digging into specific errors. Metrics are numbers over time. CPU usage, request count, error rate. Good for seeing trends, overall health, setting alerts. And traces follow a single request as it jumps between different services. Shows you where the time is spent, where bottlenecks are in a distributed system.
So logs are what, metrics are how much, traces are where.
That's a great way to put it. You need all three for the full picture. Tools. Prometheus and Grafana are huge for metrics. OpenTelemetry is becoming the standard for tracing, and the ELK stack Elasticsearch, Logstash, Kibana is common for logs. And, like testing, AI is creeping in here too. AI-powered anomaly detection and monitoring tools can spot weird patterns in metrics or logs automatically, often before a human would notice.
That's powerful. Okay, nearly there. Event-driven architecture. We mentioned services talking, but why this specific style of talking, using events?
It's mainly about decoupling and resilience. Instead of Service A directly calling Service B, Service A just shouts out, "Hey, something happened," publishes an event. Then Service B, or C, or D, if they care about that event, can listen and react. Service A doesn't even need to know Service B exists.
So if service B is down?
Service A doesn't care. The event might sit in a queue waiting for B to come back online. It makes the whole system less brittle, more asynchronous. Services can evolve independently. Tools like Apache Kafka, RabbitMQ, or cloud services like AWS SN, SSQS are the message brokers that handle these events. The pattern is usually publish, subscribe, or pub/sub. Very common, very useful.
Decoupling again. Seems to be a theme. Okay, shifting gears slightly. A more human trend. Developer experience. DX. Making life better for developers. Fast feedback, easy local setups, good docs. Why is this suddenly such a big deal? It's not just about happy devs, is it?
Well, happy devs are good, but it's more than that. Good DX directly impacts the business. If developers can get set up quickly, see their changes instantly, find the docs they need easily, they ship faster, build higher quality stuff, and are less likely to leave. Bad DX is a massive productivity drain.
So what tools help here?
Things like Docker dev environments to standardize local setups. Live reloading tools, Vite for front-end, Spring Dev tools for Java, give that instant feedback. And internal developer platforms like Backstage.io from Spotify create a central place for tools, docs, services. It's about removing friction.
Removing friction, boosting productivity. Makes sense. Okay, finally, the bonus round. Notable new trends for 2025, the really cutting-edge stuff.
All right, quick hits. First, AI code assistants like Copilot, Code Whisperer, Tab9. They're getting smarter, helping write code, find bugs, even refactor. Big productivity boost. Second, LLM agents. This is AI going beyond just suggesting code, actually planning and executing development tasks. Still early days, but potentially huge. Third, quantum-inspired computing. Not full quantum yet, but using quantum ideas on classical computers for certain optimization problems. Mostly research labs in niche areas for now. And fourth, green software engineering. Really important. Thinking about the energy efficiency of apps and infrastructure. Building more sustainable software, that's gaining serious traction.
Wow. Okay, that was a whirlwind tour. From microservices through AI, security, all the way to green software. You've basically just downloaded the state of software development for 2025. So thinking about all this, what does it really mean for you listening right now, navigating this digital world?
Well, connecting it all, these aren't just separate tech buzzwords. They point to a bigger shift. Software is becoming more intelligent, definitely more resilient, way more efficient to build and run. It's about automation, security from the start, scaling globally, and even making the developers' lives better. The pace is just incredible. It really redefines what's possible.
Absolutely. And maybe a final thought to leave you with. As all these trends keep pushing forward, how might they change not just how software gets made, but the actual experience you have with technology every day? Could apps become hyper-personalized, more reliable, maybe even visibly greener? How might your digital life feel different in ways we can't quite predict yet? Something to think about. Thanks so much for diving deep with us today. Keep exploring.